Hello there! Welcome to another exciting class on ExamPadi. Today, we'll be learning about plane shapes. And in this lesson, we will 1. Explore plane shapes and identify lines of symmetry in various shapes. 2. State the properties of plane shapes such as parallelogram and rhombus. 3. Discover ways to draw to scale with practical examples. Come along with me. What do you understand by the term plane shapes? It is a closed two-dimensional or flat figure. A plane shape has length and breadth, but no thickness. We have learned about squares, rectangles, trapeziums, triangles, and circles in previous lessons, and they are examples of plane shapes. In this lesson, we will look at 3 more plane shapes: the parallelogram, the rhombus, and the kite. All 3 are quadrilaterals because they each have 4 sides and 4 angles. Let's delve into the properties of the parallelogram, rhombus, and kite based on their sides, angles, and diagonals. The first we'll be looking at is the parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel and equal. In this image, in parallelogram ABCD, AB equals DC and side AD equals BC. ADDC and ADBC are of the same sides. 2. A parallelogram has 2 pairs of equal but opposite angles. This can be seen in parallelogram SPQR, where angle P equals angle R and angle S equals angle Q. The diagonals of a parallelogram bisect each other. That is, they cross one another. In parallelogram DEFG, diagonals DF and EG intersect at point K, while EK equals KG and DK equals KF. The next we'll be looking at is the sides, angles, and diagonals of a rhombus. A rhombus is a quadrilateral with 4 equal sides. The 2 pairs of opposite sides are parallel to each other. In this image, rhombus QPSR. QP equals PS, while PS equals SR and SR equals RQ. Side QP is opposite to RS and side QR is opposite to PS. A rhombus has 2 pairs of equal but opposite angles. In rhombus DABC, angle D equals angle B and angle A equals angle C. The diagonals of a rhombus bisect each other at right angles, perpendicularly. In rhombus RQPS, diagonals RP and QS intersect at point T. RT equals TP and QT equals TS. RT is perpendicular to QS. So all 4 angles at point T are right angles. And the last quadrilateral we'll be talking about is the kite. A kite is a quadrilateral with 2 equal short sides and 2 equal long sides. The 2 short sides are adjacent and the 2 long sides are also adjacent. In kite ABCD, AB and CD are adjacent sides because AB and BC are next to each other and they share a common vertex B, which is AB equals BC. AD and DC are adjacent sides because AD and DC are next to each other and they share a common vertex. D equals AD equals DC. 1 pair of opposite angles of a kite are equal. In kite PQRS, Angle P is the angle between a long side and a short side. Angle R is the angle between a long side and a short side. Therefore, angle P equals angle R. The long diagonal of a kite bisects the short diagonal at right angles perpendicularly. Only the short diagonal is bisected. In kite ABCD, diagonals AC and BD intersect at point E. DB is perpendicular to AC and AE equals EC. Let's take a look at a few examples. Looking at this diagram, give the most specific name for the figure. Solution. Step 1. Study the diagram and identify the properties. This polygon has 4 sides, so it is a quadrilateral. It is given that 2 pairs of sides are parallel and all 4 sides are equal. Step 2. Select the most specific name for the shape shown and give the answer. A rhombus is a quadrilateral with 2 pairs of opposite sides, parallel, and all 4 sides equal. Therefore, our answer is a quadrilateral. This quadrilateral is a rhombus. To take us further in this lesson, let's talk about drawing to scale, also known as scale drawings. A scale drawing is a diagram on which a real object, for example, a book or a table, is drawn bigger or smaller while keeping the same proportions. Architects use scale drawings when they design or plan buildings. For example, when you want to build a house, you need a floor plan of the house. It is not possible to draw a diagram of the floor plan of a house on paper at its actual size because a house is too big. So, you reduce every measurement in the same proportion, and then you can fit the diagram onto a sheet of paper. A scale drawing has to show clearly what ratio was used to enlarge or reduce the object. This ratio is called the scale of the drawing. For example, a ratio of 1 to 10 means that 1 unit on the scale drawing represents 10 units in real life. For example, a ratio of 1 to 10 means that 1 unit on the scale drawing represents 10 units in real life. This ratio is called the scale of the drawing. A ratio of 1 to 10 means that 1 unit on the scale drawing represents 10 units in real life. For example, 1 centimeter on the scale drawing represents 10 centimeter in real life. A ratio of 1 to 700 means that 1 unit on the scale drawing represents 700 units in real life. For example, 1 millimeter on the scale drawing represents 700 millimeter in real life. There are 2 types of calculations involved in scale diagram. We convert real measurements to measurements we can use to draw a scale drawing. We convert the measurement given on a scale drawing to the real measurements. How do we convert actual measurements to scale drawing measurements? If you know the measurement of a real object, you can draw a scale drawing of the object. To draw a scale drawing, you need 2 pieces of information. Firstly, you need to know the actual measurements of everything that has to go onto the scale drawing. Secondly, you need to know what scale you have to use. The scale will depend on the original measurements, how much detail the scale drawing has to show, and the size of the scale drawing. Let's take a look at an example. This diagram shows a school bag. Draw a scale drawing of the school bag using a scale of 1 to 10. Solution. Step 1. Analyze the diagram and take note of the information given. The diagram shows that the height of the school bag in real life is 70 centimeters The diagram shows that the width of the school bag in real life is 40 centimeters. Step 2. Use the given scale to convert each measurement. The scale is 1 to 10, so 1 centimeter on the scale drawing represents 10 centimeters in real life, or 10 centimeters in real life represents 1 centimeter in the scale drawing. Let's first calculate the height of the bag in real life. So the height of the bag on the scale drawing equals 70 centimeters. 70 centimeters divided by 10, that gives us 7 centimeters. Let's calculate the width of the bag in real life. The width of the bag on scale drawing equals 40 centimeters equals 40 centimeters divided by 10, and that gives us 4 centimeters. Step 3. Make an accurate scale drawing and remember to add the scale to the diagram, as seen in this image. Step 3. Make an accurate scale drawing and remember to add the scale to the diagram, as it appears in this image. Converting scale drawings to real measurements. If you have a scale drawing of an object, you can calculate the actual measurements of the object. Remember, the scale is expressed as a ratio, for example, 1 to 50. This means that 1 unit on the scale drawing represents 50 units in real life. So 1 centimeter on the scale drawing will represent 50 centimeters in real life, or 1 millimeter on the scale drawing will represent 50 millimeters in real life. For example, this is a diagram showing a scale drawing of a classroom. Study it and answer the following questions. The scale of the plan is given as 1 to 50. Measure the width and the length of the diagram of the classroom with a ruler, then calculate the real dimensions of the classroom. Solution. Step 1. Measure the width, which is the shorter side of the diagram, with a ruler. The classroom is 10.5 centimeters wide on the scale drawing. Step 2. Use the given scale to calculate the width of the classroom in real life. And that will be given as 10.5 centimeters times 50. And that will be equals to 525 centimeters. Step 3. Measure the length of the classroom. Measure the length, which is the longer side of the diagram, with a ruler, or the distance from the blackboard to the wall behind students M, N, and O, bearing in mind that the classroom is 15 centimeters long on the scale drawing. Step 4. Use the given scale to calculate the length of the classroom in real life. That is 15 centimeters multiplied by 50, and that equals 750 centimeters. So, in real life, the classroom is 750 centimeters, or 7.5 meters if divided by 100 long, and 525 centimeters, or 5.25 meters if divided by 100 wide. We have come to the end of today's lesson. Here are a few questions to evaluate yourself. 1. Which is true or false? A parallelogram, a rhombus, and a kite each have 2 pairs of equal opposite angles. B. The diagonals of a parallelogram and a rhombus bisect each other. 2. Look at this diagram and give the most specific name for the figure. 3. The bedroom shown in the picture is 350 centimeters by 400 centimeters with a standard sized single bed of 92 centimeters by 188 centimeters. The bedside table is 40 centimeters by 40 centimeters. Draw a scale drawing to show the layout of the room using the scale 1:50. Thank you for learning about plane shapes with me. I hope I've impacted you. See you in our next video. Keep learning. Bye.